sometimes a variable is not already isolated. When this occurs, you need to determine which one you would prefer to isolate and finish solving the system with the substitution method. So examine each of these system of equations. Which variable would you choose to quickly solve for and why? So looking at each system one at a time, let's examine what's the format of the equations and which variable we can quickly solve for, meaning which variable, if we substitute an expression into the equation, can be easily solved for. Think about which variable will be in the equation when you only have one variable. So looking at the first system, we have y equals 4x minus 9.6 and y equals negative 2x plus 9. In both of these equations, you have the variable y completely isolated. So you will be able to really easily, in one step, go straight to your substitution. This one already has the variable y solved for in the original system, in the original equations. So you can choose to quickly use that to solve, think for x. Think if I quickly substitute this into the other equation, I'm going to have 4x minus 9.6 equals negative 2x plus 9. So you're quickly solving for the variable x because the variable y is already isolated. We already know what that variable's expression equals, or what we can substitute that variable for. Now in the second system, we have negative y plus 4x equals negative 1 and x minus 4y equals 1. So this system is a little more complicated because you have none of the variables are already isolated. So we don't know what either variable equals to be able to substitute and solve for the other. Well, think about the two equations we have and which one would be the easiest equation to solve for one of the variables at first, right? Think about the coefficients, think about the constants if there's any, think about the steps you would have to take to isolate that variable. And you should come to the conclusion that the second equation, the variable x has a coefficient of 1. So you can quickly solve for the variable x to get that x equals 4y plus 1, and then you can substitute that value for x into the other equation to quickly solve for y. So the variable you should choose to quickly solve for in this case is x, because that's the first step in the system. You have to solve for x really quickly in order to continue on with step 2 and 3. This is versus the first equation. You didn't have to solve for anything except for, because you can originally do your substitution, you can automatically go to solving for the variable x. Here you had to solve one of the equations for x before you're then solving for y. It can be a little confusing, but really just look at the system, what they're giving you, and think about which variable would you choose to quickly solve for at first. And think about that as we now go to the last system, because we have 2x plus 4y equals negative 10, and negative 8x minus 3y equals negative 12. So here, thinking of the coefficients, none of these variables have a coefficient of 1 like that middle system had, and they would all take at least 2 steps to solve for the variable. So in this case, this system, there's not really a clear-cut answer of which variable you can quickly solve for. You can solve, I would say this one is really based on opinion. It could be x or y. Maybe you would want to do that though with the first equation, because you have all even coefficients of 2, 4, and negative 10 versus negative 8, negative 3, and negative 12. So you're going to end up working more with fractions or rational numbers versus integers, but you might be working with, depending on which variable you choose in the other equation, that same situation. So really, when you don't immediately have a variable isolated, you have to make a decision. What's going to be the easiest, quickest thing to get you into step 2, to get you into doing that substitution?